In this video, we're going to take a look at how to make formulas for binary ionic compounds. So this over here is an example of a formula specifically for a binary ionic compound. We know that because there's a metal over here and a non-metal over here. And this is a formula. The little numbers here are called the subscripts. Sub means small. So it's a small number that tells you how many of those ions there are. So here we have 2 aluminums, and here we have 3 oxygens. 3 oxygens, 2 aluminums. If there's no number, for example, in the case of NaCl, that means there's actually a 1 there, but you don't have to write it when there's a 1. So again, the small numbers, they're called subscripts, and it tells you how many of each ion there is in that compound. It's actually a ratio, because if you remember, the ionic compound exists sort of as a crystal. So there's actually more than one, sodium and 1 chlorine. More than 1 sodium, 1 chlorine in this whole crystal, but it is 1 for 1. For every 1 sodium, you have 1 chlorine, so it's a ratio, really. So let's go take a look at our example here. So this means in aluminum, in Al2O3, we have 2 aluminums for every 3 oxide ions that are there. Or, like I said, if there's a 1, it means implied. So we don't have to write the 1, but we know there's 1 sodium for every 1 chloride ions that are there. So let's go take a look at how to name if you're given a formula. Or sorry, how to write a formula if you're given a name. So here we have magnesium chloride. This is the name, and we want to write a formula. So what we do is we write the symbols of the elements side by side with their charges at the top. And their charges can be found in the periodic table. So if you look over here, in our periodic table, magnesium has a charge of 2+, right here. And chloride has a charge of 1-, right there. So we can write those side by side with the metal on the left. So Mg would be 2+, and Cl would be 1-. What we can do now is we can circle these and do what's called a crisscross. You bring the charge of the non-metal down to the metal, and you bring the charge of the metal down to the non-metal. And then you drop the plus and minus, and you just write the numbers. Mg, 1, Cl, 2. Don't forget that because this is a 1, you don't have to write it. So your cleaned formula is Mg, Cl, 2. That's called the crisscross method. That's one way you can do it. Another way you can do it is by doing what's called a charge balancing method. What that basically means is that when you have your ions in a compound, like magnesium chloride, Mg2+, and Cl, 1-, overall, the charge must be equal to 0 in a compound at the end. So you look at this and you say, well, is my charge equal to 0? Right now we have 2+ and 1-. That's not 0. That's still 1+ or +1. So we're still too many positives right now. How do you make it less positive? How do you bring it down? You have to add another negative ion. So the ions we can add are Cl-, that's our negative ion, 1- or -1. So now together these are 2-, and this is 2+. So now this is 0. 2+ and 2- is 0. So what did you just draw out here? Well, you drew 1 magnesium, so you don't have to put the 1, and you drew 2 chlorides. That's called the charge balancing method. It actually works. It's pretty easy. In some ways, it's actually less work when the compounds become more complicated than name. You can do any method that you want. You can do either charge balancing or the crisscross method. We're going to try another example here. We'll do aluminum nitride. So aluminum nitride, same thing. You go to your periodic table and you find that aluminum is 3+, and nitride is 3-. You circle, you bring the charges down to the opposite sides, crisscross. You drop the plus and minus, and you simply leave the numbers. Now the difference here is that you'll notice that the 3 and the 3 can be simplified. It's almost like if you have 2/4. That can be simplified to 1/2. So for ionic compounds only, I'm saying for ionic because later on for molecular compounds you won't do this, you need to reduce at the end. So I can reduce or simplify by dividing both of these by 3, and they become 1 and 1. Right? This becomes 1 and 1, and so you don't have to write that anymore. You just write AlN. So there's 1 aluminum and 1 nitrogen. So that's the extra rule. In cases where you can reduce, you must reduce. Okay, so you must reduce or simplify for binary ionic compounds and for other ionic compounds. You didn't have to do that here because it was already 1 to 2. 1 over 2 is already as simplified as you can get. Now, watch this. If you were doing the charge balancing method, you would have had Al3 plus and 3 minus. 3 plus and 3 minus, already 0. You just had to do one of these and one of these. Therefore, you simply had ALN. So when you do charge balancing, as long as you add and subtract everything properly, you don't even have to reduce because it's already done for you. Now you should pause the video and try barium iodide. Write a formula for barium iodide. So hopefully you paused the video and you tried it yourself. Let's go take a look if you got the right answer. So barium in your periodic table you see is 2 plus. Iodide you see is 1 minus. You bring the 2 down here, you bring the 1 down here, and that gives you Ba. We don't need to write 1. I 2. If you did the charge balancing method, you would have done Ba 2 plus, I 1 minus. It's not 0 yet. We're too many positives. We're actually plus 1 right now because we have 2 plus and minus 1. So I can add another negative ion. Now 2 plus and 2 minus make 0. How did you do that? How did you get to 0? Well, you drew 1 barium and 2 iodides, like that. Notice there's no pluses or minuses in my final formula, and everything is reduced. So the last page is a bunch of practice problems for you to try out. I recommend you pause the video, and then you check your answers afterwards using this video. So hopefully you pause the video and you try these on your own. You'll see for calcium nitride, you had Ca 2 plus, N 3 minus. When you crisscross, you get Ca 3, N 2. Sodium fluoride, you had Na 1 plus, F 1 minus. When you crisscross, they both have 1s as their subscript, so you don't have to write them. Na F. For calcium oxide, you had calcium 2 plus, O 2 minus. When you crisscrossed, you notice that you got Ca2O2. Hopefully you didn't stop here. You had to reduce after. If you did charge balancing, it would have taken care of itself. Now they're both 1 and 1, so we have CaO. Barium sulfide is similar to calcium oxide. Barium is S2 minus. Barium is 2 plus. S is 2 minus. When you crisscross, you would have got Ba2S2. You would have had to have reduced here. Again, if you did charge balancing, it would have been taken care of for you already. And you would get BAS, BA1, S1. You don't have to write the 1s. For aluminum bromide, you had Al3 plus from the periodic table, Br 1 minus. When you crisscross, the Al has a 1, so you don't have to write it down. The Br has 3. 1 aluminum, 3 bromides. Silver iodide, you maybe had to look for silver for a bit since you're not used to dealing with that one. Silver is Ag, Ag plus 1 or 1 plus. Iodide is 1 minus. When you crisscross, you'll notice they both have 1s. And so because they both have 1s, it's simply AgI. Let's go into a few more sample problems here. So again, hopefully you pause the video and you're just checking your work at this point. Potassium bromide, nice and simple. K1 plus or plus 1, Br 1 minus. That gives us KBr when you do your crisscross because you'll have 1 and 1 there. Hydrogen sulfide, again, is a bit of a weird one because it's not really ionic. It's just an exception here. For now, you could treat it like that. You could say 1 plus S2 minus. When you crisscross, you get H2S. And we'll come back to this example later. Let's focus on those other ones, though. So sodium phosphide. Sodium is Na 1 plus, phosphide 3 minus. Crisscross, you get Na3, P1, but you don't have to write the 1. Barium oxide, very similar to calcium oxide, 2 plus, O2 minus, it's already balanced charge-wise, so you would just have BaO, but if you do crisscross, you do Ba2, O2, reduce, and you get Ba1O1, but you don't have to write 1, so BaO. Barium iodide, barium we saw is 2 plus, iodine we saw is 1 minus, bring the 1 down there, bring the 2 down there, and we get BaI2. You don't have to write 1 next to the Ba. Magnesium iodide, Mg 2 plus, I 1 minus, bring the 1 down there, bring the 2 down there, and you get Mg I2. Potassium oxide, K is 1 plus, O is 2 minus, crisscross. Now K has a 2 next to it, O has a 1, but you don't have to write it, so you have K2O. And so that should have been sufficient practice for binary ionic compounds. Remember that they are compounds that have a metal and a non-metal, and you name them by simply naming the metal first and then changing the element, the non-metal ending, to IDE. And when you're trying to write the formulas from a name, you have to write the charges side by side with the metal first, non-metal after, crisscross the charges and reduce if you need to, or simply charge balance until you get to 0. In the next lesson, you'll learn how to name ionic compounds with polyatomic ions.